What's up, guys? How's it going? So today we're moving in to 2.1, which has to do with distance, slope, and midpoint. So we're going to be learning some of this so it helps us out whenever we move on further into geometry. So this is some stuff that you might have learned inside Algebra 1. So this is going to kind of be a refresher, and it's all coming together to help you out with geometry. So the first thing we're going to talk about is something called slope. So we obviously, slope is known as rise over run. So y'all remember it's also known as rate of change. So at what point something is changing at the rate of change. So we know if I have two coordinates known as x1, y1, and x2, y2, I'm going to plug them into this formula and it's going to end up giving me my slope. So with that being said, this is known as slope, which is rise over run. So for instance, if I'm given two coordinates, so let's say the two coordinates, and you can write this to that little open area on your notes. So if I was given the coordinates 3, 5 and the coordinate negative 6, 3, I could then find the slope by labeling these and plug them in the formula. So let's do that real quick. So x1, y1, x2, y2. So here's my formula. So I'm going to do y2 minus y1. So y2 minus y1 over x2 minus x1. So x2 minus x1, which is going to be 3. And so now I just work it out. So 3 minus 5 is going to give you negative 2. And then negative 6 minus 3 is going to give you 9. Double negative is going to turn into a positive. So your slope is going to be 2 over 9. So that means if I was on a coordinate system, I would go up 2 over 9. Up 2 over 9. So up 2 over 9. Up 2 and over 9 if I was doing my slope. And that's how that would work, okay? And so right underneath your slope, you have a couple of vocabulary words that I'm gonna have pop up right here, okay? So the first one is parallel lines obviously have equal slopes. Perpendicular lines have negative reciprocal slopes. And then some lines are neither parallel nor perpendicular. All right, next up on 2.1, we have something called the distance formula and the midpoint. So we actually did everything in the last playlist, or the last unit, we did everything with just a number line. And so today we're doing everything on a coordinate system. So on distance formula, this is the formula you're going to use whenever you're trying to find the distance between 2 points on a coordinate system. So if you're given a coordinate A, which is x1, y1, and you're given coordinate B, which is x2, y2, literally all I'm going to do is plug everything into the formula and work it out, and it's going to give me the distance between 2 points. So right here I would plug x2 into x2, I would plug x1 into x1, I would plug y2 into y2, and y1 into y1, and whenever I work this out, this is going to give me the distance between 2 points. So now, on the midpoint formula, if you're given a line on a coordinate system between 2 points, you would need to find the midpoint between those two. And whenever you solve for this, it is going to give you the coordinate of the midpoint. So the main thing you need to understand is going to give you the coordinate. So the same thing, if I was given A, which is x1 and y1, and I was given B, which was x2 and y2, I would then take x1 and x2 and add them together. I would take y1 and y2 to add together and divide both of those, and that would then in return give me the midpoint. So now let's jump over, and we're actually going to work some examples that are going to help us understand this. All right, so on example number 1, it tells me to find the distance between the coordinate 2, negative 1 and negative 2, negative 3. So literally all I'm going to do is write down the distance formula that you have in your notes. So D is equal to, parentheses, x2 minus x1 squared plus y2 minus y1 squared. So what's going to help me out is if I go ahead and label my 2 points. It doesn't matter where you start as long as you label them. So I'm going to make these the 1s. I'm going to make these the 2s. So let's go ahead and plug everything in. So x2 right here is negative 2. x1 right here is 2. So parentheses squared. y2 right here is going to be negative 3. And then y1 here is going to be negative 1. And I'm going to square that. And then I have to take the square root of the whole thing. Make sure you do not forget that step. So let's go ahead and solve for this. So I'm going to do the parentheses first. So negative 2 minus negative 2 is going to give me negative 4. Negative 3 minus a negative 1 is going to be a plus here. So negative 3 plus 1 is going to give you negative 2 squared. And I have to take the square root of the whole thing. So negative 4 times negative 4 is going to give you 16. Negative 2 times negative 2 is going to end up giving you 4. 16 plus 4 is going to give you 20. So your answer here is going to be the square root of 20 because there is not a square root of 20. Now we could simplify that, but we're just going to leave it as the square root of 20. So right here, ladies and gentlemen, your distance between 2, negative 1 and negative 2, negative 3 is the square root of 20. All right, so now in example number 2, it wants me to find the midpoint between the two. So literally all I have to do is go look back on my notes here and write down the formula. So I'm going to do x1 plus x2 and then divide it by 2. Then I'm going to do y1 plus or y2 divided by 2, and that's going to give me my coordinates for my midpoint. So let's go ahead and label this and plug it in. So x1, y1, x2, y2. And let's plug this in. So x1 is negative 1, x2 is negative 2, y1 is negative 1, y2 is negative 3. So now all I got to do is work it out. So negative 1 plus negative 2 is negative 3. Negative 1 plus negative 3 is negative 4. Negative 3 divided by 2 is going to be negative 1.5. Negative 4 divided by 2 is going to be negative 2. So ladies and gentlemen, your coordinate for the midpoint between 2, negative 1 and negative 2, negative 3 is going to be negative 1.5, comma, negative 2. All right, guys, so now on example number 3, you're given a coordinate or a coordinate system, and I'm going to put that up here in the corner. And right now, if you look, it wants the midpoint between A, B, and we're going to make that point C. So right now, if I look here, I need to write down my two coordinates, then I need to write down my midpoint formula. So my two coordinates, A, B, if I count over 4 and down 3, that's going to give me coordinate A is going to be 4, negative 3. B, if I count over 6 and up 4, that's going to give me the coordinate 6, 4. Okay, so now let's go and write down my formula. So x2 plus x1, x1 plus x2 divided by 2. And then you got y1 plus y2 divided by 2. And let's plug in. So I'm going to label x1, y1, x2, y2. So here we go. So x1 is going to be 4. x2 is going to be 6 divided by 2. y1 is going to be negative 3. y2 is going to be 4 and divided by 2. Okay, so here we go. So 4 plus 6 is going to be 10. 10 divided by 2 is going to give you 5. Negative 3 plus 4 is the same thing as 4 minus 3, which is 1. 1 divided by 2 is going to be 0.5, but I'm just going to go ahead and leave it as 1/2 because we know 1/2 and 0.5 are the same thing. So the midpoint between A and B is going to be 5, comma, 1/2. All right, guys, so now on example number 4, if you look, it says the distance between point L and point M is this formula right here. And it says, what are the coordinates of point L and point M? So right now, if you look, this is basically the distance formula with everything plugged in. So now what it wants me to do is take everything out to show you what the two coordinates are. So what I'm going to do is I'm going to go ahead and draw the distance formula right next to it. So it should be x1 minus, or it should be x2 minus x1 squared plus y2 minus y1 squared. So now I'm just going to match up and I'm going to take everything out here. So I'm going to go ahead and make L the 2's and I'm going to make M's the 1's. Okay, so let's go ahead and do this. So x2 and y2 go together because that's what we pulled earlier. So right now x2 is 4, so I'm going to put x is 4 and y2 is 7. So that means the coordinate of L is going to be 4, 7. Okay, now M, I made those the 1's, so I'm going to pull out the 1's. So right now if you look, I'm subtracting both of these. So I'm subtracting negative 4. So what that means is x1 is going to be negative 4. So x1 is negative 4. y1, look, we're subtracting it, so that means what's next to the subtraction is going to be y1. So y1 is going to be negative 3. So ladies and gentlemen, the coordinate of L is 4, 7, and the coordinate of M is going to be negative 4, negative 3. All right, guys, and lastly on example number 5 here, it tells me you have points A, negative 2, 3, point B, 4, negative 6, and point C, 8, 5. And what those do is those three coordinates are going to form a triangle on a coordinate system. And it says, then what is the length of BC? So we want to know. So we want to know the length of BC. And the way we do that is we are going to use the distance formula. So D is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay? So here we go. So BC, I'm going to take coordinate B and coordinate C. So I'm going to label the B's the 1s. I'm going to label the C's the 2s. Okay? So here we go. Let's go ahead and write this out. So right now, x2 is going to be 8. x1 is going to be 4. So I'm going to subtract those and square it. y2 is going to be 5. y1 is going to be negative 6. And I'm going to square that. Then I take the square root of that whole thing. So let's go ahead and work it out. So 8 minus 4 is going to give you 4. 5 minus a negative, so that's going to turn into plus, right? Then 5 plus 6 is going to give you 11, right? Okay, take the square root of that. So right now, 4 times 4 is going to give you 16. 11 times 11 is going to give you 121. Okay? So 16 plus 121. So 121 plus 10 is going to be 131. Plus 6 is 137. So right here, ladies and gentlemen, the distance between point B and point C is going to be the square root of 137. So what you could do is you could actually go and type this in the calculator and it would give you a decimal. But we're just going to keep it as the square root of 137. So ladies and gentlemen, the distance between point B and point 7 is the square root of 137.